Lufs, the mystical number which tells us how loud something is perceived. Well, recently the mystique surrounding the number was demystified, and I learned comprehensively how Lufs values are calculated and how different measurement standards implement Lufs, all thanks to a really great video from AUO2 Tutorials. And in the process, it's helped me raise some questions and tests to conduct in this video. A lot of what I'm going to discuss here is in summary what I've learned from that video, plus my own thoughts and applications of the knowledge as a mastering engineer. Previously, I understood Lufs measurements as their surface value. I tried to read papers on it, but was able to make very little sense of how this was calculated. On the surface, the definition though remained the same. Lufs standardized sounds psychological correlate of physical amplitude, but what factors are taken into consideration with this standardization? First is the sound pressure level, second, frequency, third, duration. For myself, I was very aware of how both RMS amplitude of a signal and the frequency balance of a signal was filtered with K weighting in order to achieve a perceived loudness. However, the turning kicker for myself was how duration was used in calculating an integrated LUFS level. Here's the equation for calculating LUFS. Now, this calculation is taken in 400 millisecond chunks, every 100 milliseconds, and the overlapping average of these values over the duration of a piece is what gives us our integrated LUFS value. EBU R128 and ITU-R-BS1770 standards take this one step further, introducing an absolute and relative gate to the equation, removing all values from the average of the equation which are below -70 LUFS and discounting all values -10 LUFS or -8 LU below the relative current integrated value. Now, in a mastering context, when we're discussing the dynamics of material over a duration or period of time, we're often referring to the macro dynamics, which are the differences between the loudest and softest passages within a piece of music. Armed with this information, I thought it'd be fun to test a few aspects of macro dynamics with the aim of manipulating the integrated LUFS readout. Alright, so let's do some tests. We know a couple of things about loudness. So integrated loudness is calculated throughout the duration of the track. It is a sum of the averages of 400 millisecond chunks with every 100 milliseconds overlapping. Now, any of those values that are below -7 LUFS, as we've said, get gated out. They're not included. But also, any values, given that we're using the ITU standard, which is what Spotify uses, any values -10 loudness units below the average is also just, hey, we're not calculating that in the equation. So I did a few things to manipulate how we can change those LUFS readouts. The first one is volume automation. During this breakdown section, it gets below that -10 LU level, so it's not getting calculated anymore. I did a volume ride there, and then also brought this pre-breakdown, this sort of pre-chorus section down a couple decibels, and I was able to get the readout to be -8.7 LUFS instead of -8.4 LUFS. That's pretty interesting. Not a huge difference there. Then I chose to just go crazy, change the arrangement. Let's make the breakdown twice as long. Let's make the chorus half as long. That actually had a big effect. Without any volume automation, that brought the nominal loudness units to -8.9. So that's the new integrated readout. Then I thought, what happens if I do both volume automation and change the arrangement? Well, then I got the overall loudness units down to -9.3. Now, mind you, I want everybody to keep in mind with this, I'm not changing the loudness of the chorus. The drops are exactly the same overall loudness. It's just that I'm manipulating the integrated readout. Now, so I changed that. I thought, well, there was one more thing I could do. Now, in these sections here, there's some vocals playing. It's in the breakdown. And in between the vocal phrases, it always drops super, super soft. And I'll get my loudness meter. I'm going to have dB relative. I'm not going to use the BS standard, only because that's going to affect the readout. So look in between the vocal phrases. It drops really low, the short-term loudness.
Run away from me. I'm lost in them holes.
So it drops really low, and I was like, well, that's also going to affect my average overall loudness. So I thought, what happens if I use some upward compression with the compressor, and I bake this into the using the audio suite. I used some parallel compression, so those phrases in between would just, those lower levels would just come up a little bit and help my readout a little bit more, because I felt like some of those values were actually getting lost because they were below -10 loudness units of the average and nominal level. I did that. So between volume automation, changing the arrangement, using upward compression throughout the softer sections to make sure all those low values were included in the average calculation, I went from a track that had 8.4 integrated Lufs readout to 9.5 integrated Lufs readout. Obviously, it's a Frankenstein now because it's not actually the original track, but it was just to see how could we manipulate the overall integrated loudness. And it was really interesting because we were able to do that. Now, what are the key takeaways here? Because the key takeaways are what are important. What's the whole point of doing all this like an audio wankery unless we can actually come to some conclusion? So the conclusion is, okay, we need to understand how Lufs works. It is important to understand the mechanics of how it all fits together, okay? It's not necessarily something that should be the hard be-all and end-all to how we operate a session, but it's important to understand, number one, how it just integrates with what we're doing. Now, in understanding that, there's a key element which is completely musical, which we should also understand as mastering engineers or somebody mastering a track, and that is the macro dynamics of the material. How are those passages interacting with the music? Because, yes, we can make loud tracks, but if our breaks and our bridges or whatnot are really, really super soft, well, they're not going to get considered in a Lufs readout, nor is it always the most musical thing to do. Especially as a mastering engineer, we want to make sure people are always engaged. So sometimes those super, super soft passages, which people on the subway or on a train, when they're listening in their headphones, they're going to think that their sound went off if they're so soft. We should consider bringing them up a little bit. And relatively so, we should consider how one phrase to the next musically enhances the listener's experience. So, all in all, I think there are some little flaws in the way Lufs readouts are created, but that said, it just gives us a better appreciation for creating good macro dynamics through a piece of material. It was really fun doing this test. I didn't really come to any solid difference in the way I would be working. However, it was fun to just explore this with you because it was something that was on my mind. I still give so much credit to this original video, which I'm leaving the link in the description below. You should go watch it. It's 50 minutes long, but it's very much worthwhile the watch. And until next time, take care.